Sir, good afternoon, sir.
Good afternoon. How are you?
I'm very good, sir. What about you, sir?
I'm good. Okay.
Okay.
Okay, Shrikant, can you tell me what do you understand by the Darling-Gunton pair?
Yes, sir. It is direct coupled amplifier, which is having high current gain.
How you
And
design?
which is,
Can you draw the circuit for this?
yes, sir.
Right, please.
So
What will be current gain for this?
1 plus beta square, sir.
1 plus beta square.
Yes, sir.
Can you explain why?
1 plus beta square is no, sir. I didn't remember the clarity of that answer.
Okay, fine, not any. Can you draw one electronic switch? Can you design one electronic switch using transistor?
Yes, sir.
Try it, please. Can you explain the operation, how it is working as a switch?
Yes, sir. Actually, when we give base to the input, sir,
Okay.
then it will going to be taken like it is short circuited, like what you call. Actually, it is not gate, sir. Sorry,
So
inverter
then,
actually.
so then, will it work as a switch?
Yeah, it can work, but it is acts like reverse switch. Like when we also turn down the switch, it will going to be off.
Hmm.
Reverse operation will do. It is like not gate actually.
So then the
So
question I
we
ask,
can use this one also as a switch. So
okay, fine, not an issue. Okay, let us suppose, I need to design one circuit, right? Okay. So there is one plant where basically some temperature is there and pressure is there, right? Okay.
yeah.
I wanted that temperature doesn't go beyond the set limit, right? I
Okay.
I wanted that pressure doesn't go beyond the set limit. Let us suppose there is some fixed set limit, right? You can take for temperature, it is 279 degree Kelvin or something else. For pressure, it is
Yes.
something in particles, right? Okay.
Yes, sir.
So
Yes.
whenever in the plant the temperature and pressure goes beyond that, I
Yes, sir.
wanted my alarm circuit to be generated. How I can design?
Okay. Your temperature has to be like limited up to that. If temperature limited to
There is a there is
exceed
a
that
parti-
limit.
there is a particular value of temperature, right?
Yes, sir. Yes.
Temperature should not go beyond that. There is a particular value of the pressure. Pressure should not go beyond that. Listen carefully,
Yes.
okay?
Yes, sir.
Any of or both of these go beyond the range, then there should be some signal. There should be something like which people can understand that the signals are going beyond the range. So how I will design a circuit for that? You got my question?
Yes, sir. Like if the pressure or like temperature exceeds that limit, that system has to be turned off.
Right. No, that is up to. There is no point of turn off. Just signal should be reflected. Some LED must glow. Signal should go in some form, right? Okay, so that the people in the surrounding can understand that some hazardous condition is going to be raised. That is why the signal is arising there, right? Okay.
Yes,
Can you
sir.
tell me how you can design that?
By taking out transistors, sir. Like
How? Don't you think first you need to a temperature measuring device, temperature sensor? One you need a pressure sensor. Only then they will sensor the temperature and pressure. They will give you the reading. So there is an operational amplifier IC which I can use in the comparator mode, right?
okay,
So that value I will put there as a threshold. Whatever temperature fixed I put it, whatever pressure I put fixed. I will do two operational amplifier comparator, na. So one
yeah,
for the
yeah, yes, sir,
temperature,
yes,
one for the pressure. Whatever
yes,
range is
yes,
there, that I will take as a threshold comparator, right? Okay.
yes, sir,
So
yes,
when that value will go beyond that, the comparator output will go high. And don't you think comparator output you can give into a OR gate? And with the help of the OR gate, you can drive a LED because OR gate generated the high signal when any of the input is high. The
yes, sir,
LED will glow. Can't you do like this?
yes, sir, yes. But I
How
had
you
it
can do?
like this,
How you can do with transistor simply? Tell me how transistor will sense the temperature. Tell me, will transistor respond for the temperature?
like what you said, sir. Actually, the circuit is like here, we need to take some sensors, sir. Actually,
Yeah,
here,
that is fine.
base,
But
sir.
how the comparison? Where is the threshold value? That above this temperature, the signal should alarm. Not for all
Yes,
the
that
value
is
of temperature, right?
yes, yes, sir. Yes, there is a
Common
drawback of
sense. No, for that somewhere you need to put the comparison. For
yeah,
comparison, what you will
comparators,
put? You will put the
op amp.
comparator.
Yes, sir, op amp comparator. Yes,
Fine or not?
yes, yes, sir. Good question, sir.
Clear or not?
Yes, sir. Yes,
Can we go ahead?
like yes, sir. You can go ahead. And mostly, sir, you can ask me some kind of difficult question also, sir. And difficult means like I need to actually I studied analog electronics, digital electronics, network theory, control system. The subject I was okay fine with them, but actually when it comes to IBJO, like they are asking some kind of basic questions. Like I was seeing some videos on YouTube also, sir. But actually, I need to know some clarity. Like, array, I'm thinking myself I have some knowledge, but that is not the thing. I
Okay,
should
fine. Not
believe
an
myself.
issue. Can we go ahead
Yes,
now?
sir. Yes, sir.
Okay, what is KCL and KVL? Tell me the difference.
Yes, sir. KSL is a Kirchhoff current law, which is algebraic sum of currents at the one node is equal to zero, sir. Actually, sum of
Okay.
entering current equal to sum of current leaving, sir. Okay, that is KCL, sir. KVL means like algebraic loop. Like when if you take any loop in that one loop, algebraic voltage should be zero, complete KVL.
Okay,
So
let us suppose in my circuit the voltage applied is not sine or cos. Neither it's DC, right? Okay, fine.
yes, sir. Hmm.
It's in the form of the square, it's in the form of the triangular, it's in the form of some other, right? Okay.
Yeah. Okay, so
So how you will do the analysis of circuit? How you will apply then KCL and KVL in the circuit?
if it is not DC, but it is like square wave and triangular wave.
It's not DC, it's not sine, it's not cosine, right? It's
Yes, sir.
something else. It's AC, it's something else. It's square wave, triangular, something else. How you will analyze the circuit? Tell me.
Okay. By finding of KCL and KVL, right?
No, obviously to analyze the circuit, you will use KCL and
To
KVL. Na? In KCL,
KCL. Okay.
KVL, obviously you write expression of the voltage. On the
Yes,
one
sir.
side, the source will come. So if it's sine, then you will use the phasor form of the voltage. If it's DC, you will use the value directly. But if it's not the sine, if it's not the DC, then how you will write expression? That is my question.
Okay. Square wave means like this is one procedure I forgot, sir. Actually, apart from that, you take some procedure. I didn't get you, sir. Sorry.
Have you heard about Fourier series?
Yes, sir. Fourier series.
Don't you think square wave can be expressed in terms of the sine and cosine by using the Fourier series in terms of the harmonics?
Oh, okay, yes, sir. Yes.
And since resistor, inductive, capacitive, they are the linear circuit, you can apply the
Linear
linearity
circuit.
property. You can consider one voltage source at a time and calculate the response and add for all the voltages, right or not? Can we do like this?
Yes. We can convert this square wave into like sine wave, like by taking a Fourier series, like superimposing of sine and cos will be like sinusoidal signal,
So
and
see,
we
the
can
point
analyze.
is that you must be in position to click these things, okay? Right? These are not much
Yes,
difficult things.
of
Hmm?
course. Yes.
Okay, draw a voltage source on your copy.
Sir,
Do you have any copy?
which copies? Like,
Any notebook, any copy pen you have?
yes.
Draw
I had
draw one practical voltage source on the copy.
practical voltage source.
Yes. Now connect some resistance RL across this.
Okay.
What is the voltage across RL?
Voltage RL.
Yeah,
It
calculate
is
the
like,
voltage across RL.
sir, it is
Tell me now how you can calculate the voltage across RL. What it will be?
it will be like voltage division rule, sir. Actually, voltage at resistance that RL is equal to.
So tell me the value now. What will be that, Shrikant? You can
Okay,
quote the value. It will be Vs
okay.
into RL upon RL plus RL. Simply tell me that.
Yes, sir. Yes. V into RL. Yes, V that voltage V into RL by RL plus RL, like total
But I
resistance.
but I wanted load voltage equal to source voltage Vs. How you can do it?
Then we can take maximum power transfer theorem straight, sir.
See, listen carefully. What I'm asking, listen first carefully. Don't go after, okay? I need VL is equal to Vs without disturbing the RL value, without disturbing the source value. Tell me how I can achieve that.
By taking RS should be like 0, sir.
What I told right now, without disturbing the source property and without disturbing the load value.
Without disturbing that value means. Yeah, VL equal to VS without changing that source properties.
Yes. Any idea? Okay, can you
Source
draw
transfer.
voltage? Can you draw voltage followed by using operational amplifier?
Yes, sir.
Draw it on your copy. Are you done?
Yes, sir.
Where is your input? One you have grounded, one you have directly connected the output like this. Output is 0.
Okay, sir. This one, sir,
Where
will plus V
where is
side.
your input? Till I'm not able to get your input. Where is your input?
Input is given like plus V, like inverting to non-inverting terminal, sir. Actually, VS.
Arey bhaiya, this ground is input, right? Now do one thing.
No,
Instead of this input, connect the voltage source, whatever you drawn earlier, right?
sir.
Here, instead of this, you remove this copy.
Okay, sir. Okay.
Instead of this input, connect that voltage source which you draw earlier, right? And at output, connect that load resistance which you drawn earlier. Don't you think in this case output will be equal to Vs?
Yes, yes, sir. Yes. Yeah. Yes, yes. Of course, that is the point. Yes, sir.
So
Yeah,
uh,
application should be there.
the
Yes.
point is that see, I could have asked this question in the same way. What is voltage follower? Its voltage gain is 1. Then why it's important? Because it do that task. Okay, it remove the loading effect which
Yes.
earlier was happening there. Earlier, what happened? Because of loading effect, load voltage was very less than the source voltage. But
Yes, sir.
here, our buffer or our voltage amplifier did the proper impedance matching. Is it
Yes.
clear?
Yes.
So
Yes.
in that case, we get the output voltage is equal to input voltage.
Yeah.
Like this, you need to basically rehearsal and practice a lot of stuff together, right? It's not about I'm telling you people time and again. See, tomorrow he may ask the same question there. Okay, this is a voltage source. Okay, ये load के cross voltage measure करके बताओ, measure the voltage across the load, and you will be giving some particular voltage. Next he may ask, okay, I wanted this output voltage is equal to source voltage, do it. So there might be some IC, op-amp IC might be there available on the table. You simply
Yes, sir.
connect the wire as a feedback, and at one non-inverting terminal connect the source voltage or voltage source whatever is given to you, and at the output connect the load. Simple, right?
Exactly. Sir, actually, that is actually I study only theoretical, like what is happening. That's it. But I didn't apply it to different concepts, like
But that is
how
you
I
need to
can
do
get
now.
sir that one.
So that's what I told you. Na, see, right now it's all about your practice. See, whatever PDF I shared for this purpose, I shared. Understand the component, and whatever things you had as you told you, I studied the network theory, I studied the analog electron, you told me in the beginning, right? I studied the control theory. See,
Yes,
it's not
yes.
about remembering the concept, it's about how much capable you are in implementing the things, right? Okay,
But okay,
you
yes,
need to
sir.
think
But
of
how
that
can I get
application.
sir?
So you need to think, that is what na first stage you need to ask what is being asked to me and what component can perform that task. Like this question what I gave you, I ask you to calculate the load voltage. You know, load voltage is equal to Vs into RL divided by RL plus RS. I'm asking
Yes,
you that now do something that VL is equal to Vs. Now you start giving me solutions or make RS 0. See, we cannot change the property. Otherwise, I can do lot of stuff. I have so many ways. I don't need to change the property of source and load. Then think, okay, if I can't change these properties, then additionally what I can input. Then why problem is occurring? This problem is occurring because of the resistance mismatching. Is it clear? So I
yes,
need to
sir.
insert some device which can make a proper impedance transformation. That is why I ask you to choose the voltage follower. Like this you need to make. Like tomorrow, he might put you in the application where you need to do the frequency division. So what
Yes, sir.
immediately should come into your mind? Counter is a kind of device. Mod and counter is a kind of device, right? Okay.
Yes,
Sometime
sir.
tomorrow he may ask that you need to design a current source. See, in market voltage source is available, but if you go and ask 2 ampere current source, that is not available. So how
Yes,
to
sir.
draw it? Then immediately you need to think of the current mirror. You might have studied in the analog electronics, right?
Yes, sir. Yes, yes.
So basically, you need to think as per the requirement, what is required and what is being asked to me. Then accordingly, you need to put your mind in that direction, right? Okay, fine.
Yes, sir. How I can get sir? Actually, like as you said, same scenario I followed, but I studied only text like class notes. Just I remember the concept. That's it. But I never applied this kind of concepts like array how I can voltage should be like
But
whatever the
see, there is no
how can
particular
get
answer. Chirikan, there is no one answer for this. Na, this will come with the practice. That's what I'm telling you, right? The point, the moment you are understanding, you are. Let us suppose I asked you previously one question: Wheatstone bridge. So you all
yes,
people
sir.
are worried about what is P upon Q is equal to R by S. But start asking yourself, now what are the practical use of this? How it can be utilized? So when you start asking yourself question, only then these kind of things will come into your mind. If you will not
Mhm.
ask yourself question, if you simply read that information what is being written somewhere else, then you will be limited up to that only. Fine. So if I could have
Yes,
asked
that
you
is
question
happening.
that what is voltage buffer, you could have told me easily that sir its voltage gain is 1, sir its input
Yes.
impedance is very high, sir its output impedance is very low. Don't know what is the use of those property, whatever you're telling me. This is the use of those property what I asked you. right? Okay.
Yes, yes,
Clear or not?
yes, yes, sir.
So I suggest you prepare in this direction, start putting some stress on your mind. That is what, see, listen. Now I gave you list of experiment, right? Now there, even if you start going and just read that experiment, okay, this experiment is doing this thing, you will not get actual learning. But if you do the reverse engineering, why it is doing like this, then you will learn a lot of stuff. Getting my point or not, right?
Questioning, questioning. When I question the circuit,
Yeah. See, there is a transistor used. Why it's used? Ask yourself. No. There is a LED used. Why it's used? Ask yourself. LED can be used for only one purpose. That is for the signaling purpose, for glow purpose. Is it clear? Transistor can be used for amplification. It can be used for the switching application. Start asking yourself what kind of application it's used here, right? Okay.
yeah, yeah. When I do the questioning of that circuit, then I can go know, array, what is the purpose of that? Why it
Yes.
is placed here?
See, when you know the purpose and that all thing, then you start connecting the dots because you start reading the theories, right? Okay. So
Yes.
before that, if you're reading the theory, you are reading it like a history without knowing the things, right? No.
Yes, just sir, exactly. That is remembering. Array, this is happening like this one. We need to remember this one. When they
Preparation is
question
reverse
that,
engineering. Some circuit is coming in your front. Okay, ask yourself
hmm,
why this is being used. If you don't know, then obviously what you will do? You will do some Google, you will read some books. From there, you will get that clarity, right? Okay, fine.
yes, yes, yes,
Okay,
sir.
Shishant.
Yes, sir.
I hope you got some point to remember and you got some point how to prepare. Fine.
Yes, sir.
Uh, Prepare like this once and appear after few days again and appear for the snap with multiple mentors also, right? Okay.
Yes, sir. Actually, one question asked to, like Vijender sir asked me one question.
Okay.
You are from electronics and communication background. How it will going to help IB, Intelligent Bureau, JIO? How it will going to help?
You simply tell them, sir, it's not about my background. What I believe in today's time, where we are being surrounded by the, technology landscapes, where things are changing at very fast rate, right? So I
Yes, sir.
believe we must keep on upscaling ourselves and learning the new technology. So during my
Yes,
electronics and communication engineering, I got exposure to study the subject like some communication, which are very technology enabled, and that can play an important role in the futuristic, technology innovations. So that
yes,
is
sir.
what I believe. And apart from that, during my engineering, I have sharp my skills good enough so that you basically, I can learn any new technology in very short span of the time. That
Yes,
mindset I do have, right? Okay, like this you can answer. There is no specific because they don't need any specific knowledge of the electronics, right? But generally,
yes,
in today's time, things are changing very fastly. Tomorrow
yes,
it
sir.
might happen you joined IV, but you need to learn new technology to get to cope up with the systems, to cope up with the
Yes,
requirements of the organization. So there the
yes,
mindset and the aptitude and your skill matters. So you tell them those skill I believe I have got during my graduations, and if I give an opportunity, I can learn the new technology in very short span of the time with effectively and with productivity. Fine, right? This you can
mm,
answer. Okay.
yes, yes, sir. Okay. Thank you, sir. Thank you.
Okay.
I will
Okay.
meet you again, sir.
Okay.
Thank you
Sure.
so much.